The first we'll go over is the Cartesian hand field. Its job is to tell us where the hand is in relation to the center of your chest. This is simply a grid that uses x and y coordinates to tell us where the hand is in two-dimensional space. It works just like normal graphing does, and hopefully everyone's partially familiar with that. Right now we'll just use x and y for 2D, leaving z at 0. But soon we'll be working in 3D by adding the z-axis as well. You orient the grid so that when you're facing the audience, the coordinate system is aligned such that negative x is stage left and positive x is stage right. Positive y will be up, negative y will be down, and then positive z will be towards you, which is away from the audience, and minus z is toward the back of the audience, away from you. Next, we need to talk about the range of possible values that the coordinate system uses. There's a few ways to do it, but I'm just going to show you the simplest one for now. Basically, the size of the hand field's grid is restricted by how far your hand can physically travel from the center of your chest in any direction. In this picture here, you can see how I quantize the space. It's based on the proportions of your body, so the language can work for everyone as seamlessly as possible. The base unit is not in meters or feet, but in bodily proportions, with one unit equal to the distance from your wrist to your elbow. This unit is referred to as a standard prop unit, or just unit. And it's used everywhere in QFT. Assuming the distance from your wrist to your elbow as one prop unit, you can see that the distance between your two outstretched arms is very close to 5 units. You have one unit from the wrist to the elbow, then from the elbow to shoulder, and then shoulder to opposite shoulder, and then for the opposite shoulder to the opposite elbow, and then opposite elbow to opposite wrist. So that's 5 units. Again, keeping it simple, we'll assume that the pivot for your shoulder is actually the center of your chest. And this gives each hand a circle that is 2.5 units in radius. And there you go. So for the Cartesian hand field, the range of possibilities of coordinates available is everywhere inside this 2.5 unit circle. So here's how to use the Cartesian hand field. You start with an initial position represented by x, y, z. Remember that we're only using x and y right now because this is two-dimensional, so z will always be 0 for now. Let's start with 0, 0, 0, and you put it in parentheses like this. QFT notation works by stepping lines of code sequentially, like a vertical list. Each line represents a transformation that tells us where the hand and poi go next. So the way this works with the Cartesian hand field is through addition and subtraction. Like I said a second ago, our hand is currently at 0, 0, 0. We can write a simple line under this, which tells us how far left or right and or up or down to move the hand. We do this with plus or minus x, plus or minus y, plus or minus z. And again, it goes in parentheses like this. So if you say something like plus 1, plus 0, plus 0, that's telling you that after this line of code, the hand will be 1 unit to the right from where it was before this line of code. Since we started at 0, 0, 0, if we do the math, 0 plus 1 for x is 1, 0 plus 0 for y is 0, and 0 plus 0 for z is, of course, 0. That's going to put us at our new hand's position of 1, 0, 0. Now we can write another line of code under this one. Say plus 0, minus 2, plus 0. And this is going to tell us that the hand moved 2 units down. So we were at 1, 0, 0 before this line, and afterwards we'll be at 1 plus 0, 0 minus 2, 0 plus 0, or 1, minus 2, 0. For a third line, we could say something like plus 0.5, plus 0.5, plus 0, and that would put us at our new hand's position of 1.5, negative 1.5, 0. Now remember, there's a limit to how far your hand can travel here. So as an example, From here, I can't add a line of code that says +2 +0 +0, because normally that would put the hand at 3.5, 0, 0, which is physically impossible. There are exceptions to this, and later on we might talk about those situations where it's actually okay to notate things like this.